Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on December 24th, 2025, about 2 days ago. This paper introduces a task-agnostic way for large multimodal models to learn visual reasoning tokens without explicit intermediate supervision, and it beats direct fine-tuning across a broad set of vision-heavy reasoning tasks. The paper is titled Latent Implicit Visual Reasoning. And as we'll see later, the idea of forcing visual information through learned latent tokens ends up being a pretty powerful training trick. Figure 1 explains why forcing visual reasoning into text can be a dead end. The top row frames a visual similarity question, where describing what matters in words can get vague, even when the images are clearly different. The left panel shows a standard large multimodal model, losing fine details in text. The middle panel shows explicit supervision, which needs task-specific annotations like bounding boxes. The right panel shows LIVR, where a visual bottleneck pushes information through learned latent visual tokens so the model can pick the right option. Figure 2 spells out the core training trick, which is to force visual information to flow through learned latent tokens. This figure shows the full token stream, where image tokens and prompt tokens come first, then k-latent tokens, and finally the answer tokens that receive the training loss. The right side shows the bottleneck attention mask because prompt and answer tokens are blocked from directly attending to image tokens. The latent tokens stay connected, so they become the model's visual reasoning workspace without extra supervision. Table 1 shows that the latent visual tokens translate into higher accuracy across many vision-heavy tasks, not just one cherry-picked benchmark. This table reports top 1 accuracy for multiple-choice tasks, an exact match for counting, so improvements reflect better visual reasoning, not better guessing. The Keywin 2.5 block shows a mean gain of about 6 points over direct, supervised fine-tuning. The biggest jump is functional correspondence, which gains about 13 points. Figure 3 shows that the latent tokens actually look at the right parts of the image, which makes the visual bottleneck idea feel real rather than theoretical. The full figure area is shown here. The semantic correspondence panel highlights the reference point and the matching region, so attention clusters on the motorcycle details. The localization panel focuses on the bounding boxes around the target objects. The counting panel spreads attention across the cows and balloons, because the model needs all instances to answer correctly. Table 4 shows which design choices actually make the latent tokens work, rather than just adding complexity. The full table is shown here. In panel A, the best masking blocks both answer to vision and prompt to vision, because that forces all visual evidence through the latents. Panel B shows that a balanced Stage 1 and Stage 2 schedule performs best, so the latents learn first and then get integrated. Panel C peaks at 16 latents, while more tokens dilute attention. Alright, 2 takeaways stand out. First, the visual bottleneck forces the model to compress image evidence into a small set of learned latent tokens, and that reliably boosts performance on vision-heavy reasoning without hand-designed intermediate labels. Second, the gains generalize across tasks and models, which hints at a practical recipe for more visual, less text-bound multimodal reasoning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.